Today we're going to do a review of Chapter 3, Parallel and Perpendicular Lines. Numbers 1 to 3, we're going to use this figure on the right. Number 1 says, identify a plane parallel to plane AEF. So I'm going to locate plane AEF. Quickly shade that in. Remember, a plane is a flat surface. This flat surface happens to be a shape of a triangle. We want another flat surface that is parallel to the original. And to name this flat surface, we're going to use the same notation, so plane. I'm going to follow the same order of the original letters. So they want A, E, F, so this is going to be B, D, C. Number 2, identify a segment that is parallel to line segment EF. So here's line segment EF. Now, the parallel segment has to be on the same plane, the same flat surface, and not touch EF. So my only option here would be line segment, proper notation, follow the same order, DC. And number 3, name 3 segments that are skew. Now remember what skew means. The lines are not on the same plane, they're not parallel, and they will never intersect. They will never touch each other. So let's start by identifying segment BC. And what we're going to do is a process of elimination. We're going to cancel out all of the line segments that are not skew. So let's start off with the first scenario, which is they can't be on the same plane. So this top triangle flat surface, I can't use any of the line segments that are on that same plane. This sidewall, this rectangle, same thing. I can't use any of the line segments that are on that same plane. So what I'm left with, and I'll use green, are DE, FE, and AE. And notice for each one I use the proper notation of the bar across the top. Alright, numbers 4 through 7. We're dealing with parallel lines cut by a transversal and the angle relationships that are formed. Number 4. Name 4 sets of corresponding angles. Remember what corresponding means. Same location, just shifted down along the transversal. So let's start with this angle 2. I'm going to trace it. Angle 2, I went down and over to the right. So when I shift down this transversal, angle 6, to trace it, would be the same location, just shifted down one. So angle 2 and angle 6. I use a different color for a second set. So let's look at angle 1. Now when I traced it, I went down and to the left. If I go down the transversal, this angle 5, down over to the left, has the same shape. It's in the same location, just shifted down the transversal. So angles 1 and 5, my second pair. Let's use green. Angle 3, while I'm here, I want to travel down that transversal. It's going to go in the same direction. So angle 3 and angle 7. And my last one, angle 4, the matching one, angle 8. Number 5. Name 2 sets of alternate exterior angles. Now with alternate exterior angles, think about the location. You have your 2 parallel lines, And here's the space in between the two lines. So this is going to be the interior. Anything outside is going to be exterior. I have my transversal going across my two parallel lines. So for alternate exterior angles, I have to cross that red transversal to get from one to the other. So here's an angle on the outside, the exterior. So angle 1. I need another exterior angle that I cross the transversal to get to. So angle 1 and angle 8, to get from one to the other, I cross the transversal, so they're on alternate sides of that transversal. Another set would be angle 2 and angle 7. They're both on the exterior, and to get from one to the other, I have to cross that red transversal. Number 6, given that line A is parallel to line B, and the measure of angle 2, so let me trace that. Here's angle 2, is 25. Find the measure of angle 6. Well, when I trace them, I notice that they're in the same location, just shifted down one, so these are corresponding angles. And when the lines are parallel, corresponding angles are congruent. Congruent means they're equal. So if angle 2 is 25, angle 6 is also 25. Number 7. A and B are parallel to each other. Angle 3, let's trace that, is 2x plus 6. And angle 5 is 4x plus 18. Find the value of x. Anytime they ask you to find the value of x or y or z, what they're wanting you to do is set up an equation. So you're going to go back to algebra 1. Set up an equation and get your x by itself to get the value. Now before we can set up an equation, we have to figure out what kind of relationship we're dealing with. In this case, angle 3 and angle 5 are both on the interior space, but they're on the same side of that transversal. So these are consecutive interior angles. And you learned that consecutive interior angles are supplementary. And what that means is the two angles together add up to equal 180 degrees. So I have my first angle, which is angle 3, plus my second angle, angle 5, together add up to 180. Now I'm going to rewrite the same equation, but I'm going to plug in, I'm going to substitute for angle 3 and angle 5. So angle 3, they told me, was 2x plus 6. And angle 5 was 4x plus 18. Bring down my equals and my 180. Algebra 1, group like terms. So 2x plus 4x gives me 6x. 6 plus 18 gives me 24. Bring down my equals, 180. Algebra 1, I need to get this x by itself, so I'm going to subtract 24 from both sides of my equal sign. Whatever you do to one side, you do to the other side. Bring down what's left. I need this x single, so I need to get rid of that 6. I'm going to divide both sides of my equal sign by 6. And what I'm left with is x is equal to 26. Eight and 9. Again, we're dealing with parallel lines cut by a transversal. With 8, they tell us that we're dealing with angle 2 and angle 6. And they want us to find the value of x, which means we need to come up with an equation. Now, these two angles, 2 and 6, are both in the interior space on opposite sides of the transversal. So these are alternate interior angles. And alternate interior angles are congruent. Congruent, remember, is that little symbol, equal sign with the little squiggly above it. So angle 2 is congruent to angle 6. We know congruent means equal. So if I substitute for angle 2 what they gave me, which was 7x plus 6, and for angle 6 they gave me 10x minus 9, I now have my equation to solve for x. So algebra 1, let's reunite my x's. So I'm going to move the smaller one, bring down what's left. Now I need to move this negative 9, so the opposite is positive 9. Bring down what's left. I need x single, so I'm going to divide both sides by 3. So my x is equal to 5. I don't need to plug it in because all they wanted was x, so this is where I'm going to stop. Number 9. In this one we're working with angle 2, so I trace it, and angle 3. Well, we see that they're both on the interior and they're both on the same side of the transversal, so these are same side or consecutive interior angles. Consecutive interior angles are supplementary, which means they add up to 180 degrees. Here, they told us that the two angles add up to 180 degrees, so I'm working backwards. I want to know the name of the postulate or theorem that proves that the lines are parallel. Well, here's an easy way of naming a postulate or theorem. Start with the name of the relationship. So we have consecutive interior angles. Since we are working backwards, we're proving the lines are parallel. Backwards, we're going to add on converse. The last part is it a theorem or a postulate? Well, in this unit, you only learned one postulate, which was corresponding angles. Everything else is a theorem. That's a little trick. So the name of the postulate or theorem that justifies L is parallel to M, converse of consecutive interior angles theorem. Alright, let's move on now to equation of a line. For 10 and 11, they want you to use this formula for slope of the line. Anytime you're dealing with coordinates and an equation, the easiest thing to do is label the coordinates. For every point, you know you're going to have an x and a y. So point C has an x and a y, point D has an x and a y. This is my first point, so these are going to be my sub 1s. This is my second point, so these are going to be my sub 2s. That way, it makes it easy to plug into the formula. So let me copy that formula. The first thing they want is my y sub 2. So y sub 2 is 5 minus y sub 1. Y sub 1 is negative 1. Notice what I did. The equation itself had a minus and the point had a negative. I have to write both of those. But don't worry, we're going to clean this up in a little bit. For the bottom, x sub 2 is negative 1 minus x sub 1 is negative 3. Now remember I told you we're going to clean this up? Double negative becomes a positive, so I rewrite this as 5 plus 1. On the bottom, I have negative 1. Again, double negative becomes a positive 3. 5 plus 1 is 6. Negative 1 plus 3 is 2. Simplify this, and the slope of that line is 3. Let's move on to number 11. Again, label. Every point has its own x and its own y. This is my first one, so here are my sub 1s. This is my second one, so here are my sub 2s. Copy the formula. and then plug it in. Y sub 2 is 0 minus y sub 1, 7, over x sub 2 is 7 minus x sub 1, which is 0. 0 minus 7 is negative 7. 7 minus 0 is 7. Simplify. Slope of this line is negative 1. Halfway. Number 12. Write the equation of a line with a slope of 5 and a y-intercept of negative 2. Hope and pray that the test has a question like this, because this is an easy one. The standard form of the equation, y is equal to mx plus b, where m is your slope and b is your y-intercept. So they gave you the slope and they gave you the y-intercept, so all you have to do is plug in. So rewriting the same equation, y is equal to m, my m is 5, x plus b is negative 2. Well, this is kind of ugly here with the plus minus. So I'm going to rewrite this. Y is equal to 5x minus 2. Nice and easy. Number 13. We're going to write an equation of a line again, but this time it's going to take a different form. Here they gave us the slope and they gave us a point. So what we're going to use is the point slope form of the equation. I'm going to write this down over here. Point slope form of the equation is y minus y sub 1 equals m times x minus x sub 1. We already have the m, so we're going to plug that in here. But the point, again, each point has its own x and its own y, so we label. This is my only point, so this is going to be sub 1s. I'm going to plug these in. Y minus my y sub 1 is 2 equals my m is 4 times x minus my x sub 1 is 5. And we can stop here and check to see, are any of these close? Yep, right here. Nice. Number 14, let's bring equations into real life. Yoga lessons cost $6, and I'm going to underline stuff as we go through, per lesson if Kylie enrolls in a health club for a fee of $130 per year. Suppose Kylie joins the health club. Write an equation that represents the yearly cost C of L yoga lessons. Alright, so the cost we know is $130 per year regardless of how many yoga lessons Kylie takes. So this is my cover charge. This is my constant. What's going to change is how many yoga lessons she takes. Well, we know it's $6 per lesson, and we're going to use L to represent each lesson. So if she takes no yoga lessons at all, she's out $130. If she takes one, it's $130 plus 6, and so on and so forth. So here's my equation to figure out her cost. What is the distance of point P, so here's point P here, to line M? Well, how far apart? Let's count boxes. 1, 2, 3, 4, 5, 6. So this is going to be 6 units apart. Number 16, we don't have a graph, so we're going to freehand it. And I apologize, mine is going to be a little shaky here. I'll do the best I can. So here's a quick x-axis, y-axis. And we want 2 lines. First one is y is equal to 6, so let's say 6 is right here. So I'm going to use a dashed line to represent y is equal to 6. And for the second one, on the y-axis, I'm going to find 10. Let's say it's about here. Again, I'm going to use a dashed line. And this one is y equals 10. And what I want to know is how far apart are these 2 dashed lines? Well, the difference between 10 and 6 is 4 units. It's another nice easy one. Alright, let's close this out. For 17 through 20, we're going to use this figure. Now this looks like it's going to be a hot mess. What we're going to do is break it up into bite-sized pieces. In number 17, they want to know all 8 pairs of consecutive interior angles. So what I'm going to do is work left to right first. So I'm just going to focus on this section. Ignore everything else at the bottom. And remember, consecutive interior angles. Interior, we're just dealing with the space in between the lines, and they're going to stay on the same side of my transversal. So we have angle 2 and angle 5. That's one pair. See, there's a different color here. We have angle 3 and angle 8. So there are 2 pairs. We need 6 more. Let's go to this second set. So we're going to ignore the top part. Again, space in between. So we have angle 10. We're going to stay on the same side of that transversal. Goes with angle 13. And let's use pink. Angle 11 and angle 16. So we're going left to right. So that's 4 pairs. Now let's change it up and go up and down. So for my up and down, here's my first set. We're dealing with the space in between those 2 lines on the same side of the transversal. So we have angle 4, angle 9, angle 3, and angle 10. So we're now at 6 pairs. Let's do our last set. Again, going up and down. In between the 2 lines. So here's angle 8, staying on the same side of the transversal. Angle 13. And finally, angle 7 and angle 14. If you use colored pencils with an eraser, it makes it a lot easier to find them. And of course, as you're going through, you're writing down in proper notation your pairs. Alright, let's move on to number 18. Name all 16 pairs of corresponding angles. Alright, corresponding angles, remember, same location, just shifted down along the transversal. Alright, so again, we're going to go the first set. So here we have angle 1, angle 5. Notice they're both going in the same direction. Angle 2, angle 6, same direction. Angle 4, angle 8, and angle 3, angle 7. 4 pairs, 12 to go. Let's do the second set. Angle 9, matching angle 13. Angle 10, matching angle 14. Angle 12, matching angle 16. And angle 11 matches angle 15. So that's 8 pairs, halfway. So we went side to side, now let's go up and down. Alright, my first set going up and down. Matching. Angle 1 goes with angle 10. Angle 3 goes with angle 11. Angle 1 goes with angle 9. And angle 4 goes with angle 12. So we're now at 12 pairs. Our last set going up and down. Angle 5 goes with angle 13. Angle 6 goes with angle 14. Angle 8 goes with angle 16, and finally angle 7 goes with angle 15. Matching, same location. Alright, so that takes care of all 16 pairs. Remember proper notation. Number 19. Still using the same image. Given that angle 9, so let's find angle 9. Here's angle 9. Is congruent to angle 15. Alright, I want to isolate this section, so that way I'm going to ignore this top part. Here are my two lines cut by my transversal. Angle 9 is on the outside, angle 15 is also on the outside. Here's my transversal cutting across both. To get from 9 to 15, I cross that transversal. So we know that they were on the exterior, so they're exterior angles. And to get from one to the other, I crossed the transversal, so they were alternate. Exterior angles. And we're working backwards to prove the two lines parallel, so backwards we put on converse of. The last part is determining, is it a theorem or a postulate? We know postulate is only corresponding, so this is theorem. And here's that little shortcut on naming the theorem. So the answer is converse of alternate exterior angles theorem. Number 20, our last one. Given that angle 3, so let's find angle 3, and angle 7 are congruent. I want to isolate this, so here's the section I'm working with. Ignore everything below. My transversal, let's use green for our transversal this time. It's right here. These two red angles are on the same side of that transversal, but notice that they are in the same location. They're in matching spots. So these are corresponding angles. They tell us that they're congruent, and we're working backwards to prove that the two lines are parallel, so we're going to put converse of, and the last part is theorem or postulate. This is corresponding, this is the only one that is a postulate. So my answer, converse of corresponding angles postulate, that proves that these two lines are parallel.